moving on. We've talked that ultrasound can be used for medical imaging. An example in which ultrasound can be used for medical imaging is to monitor the inside of a pregnant mother with the aim of understanding what is happening inside. How can we be able to view the inside of a mother without opening the stomach, because that will harm the child, right? So to use ultrasound, we're going to need what is known as a probe, right? Or a transducer that's going to produce ultrasound as well as detect the reflected ultrasound. So we're going to have something like that. We're going to have a monitor that is used to view the pregnancy scan. And then we're going to have a mother over here. Then we're going to move the probe up and about over the stomach of the pregnant mother with the aim of being able to view the inside or the internal structure of the baby. So the first one, the transducer will send out a pulse of ultrasound waves. So if we're here, the transducer is this. It's going to send out a pulse of ultrasound waves, and those pulses are going to intercept with the child. Okay, so we apply a gel on the surface of the baby. We'll talk about why that gel is important a bit later. But we have a gel that is applied, and that gel is used to minimize reflections. We'll explain what that is in a bit. The ultrasound pulse will be reflected on the surface to be diagnosed. So if you have a surface, let's assume the leg of this little baby, right? It's going to get reflected on that surface, then it come back to the probe, come back to this detector, right? So how exactly do we detect this? You might actually wonder, how exactly do we detect what's happening here? Okay, so let me give you an illustration. So let's assume we have a baby, right? Let's make this animation. So we have the stomach of the mother over there. We have the first layer, the jelly that the baby is in. That's our baby. Okay, so you have a probe that's on top over there. So the probe is going to send an ultrasound pulse, right? So the ultrasound pulse is going to travel through the tissue of the mother, through the jelly, and then reach the baby, right? So ultrasound gets reflected whenever there's a boundary, right? So if you have light hits the water, then it gets reflected, because there's a boundary between the water and the air. The same is happening with ultrasound. If it arrives at a boundary, either the boundary between the tissue of the mother and the jelly, or where the baby's in, is going to get reflected, right? Or if it keeps on moving and it hits the stomach of the belly of the baby, it's going to get reflected. If it hits the foot of the baby, it's going to get reflected. If it hits the head of the baby, it's going to get reflected. So if that sound gets reflected back and forth, back and forth, back and forth, you're going to get information about the depth from the time delay. What do I mean by this? So if you send a pulse and it takes 3 seconds to be able to reach the baby, then 3 seconds to come back, that's 6 seconds in total, you can therefore estimate how deep that point where the reflection occurred is. Okay? If you have another point that's a slightly shallower, and it takes 2 seconds to hit that, 2 seconds to come back, you know the speed of ultrasound, you can therefore be able to estimate how deep that structure is, and so forth and so forth and so forth. So you can be able to map how deep those boundaries are just by measuring how long it took for the transmitted wave to return back to where it was sent. And then when an ultrasound wave hits a boundary between two different materials, we have muscle, we have bone, fluid, or tissue, the wave gets reflected and part of it continues to travel through. The intensity of the reflected wave, that is how strong or weak the wave is as it comes back, will tell you the different structures that are present. What do I mean by this? If I give you the stomach of the baby, the wave is good. Some part of the wave is going to be absorbed, right? Because it's a change in boundary from the skin of the baby inside, right? But some of it is going to get absorbed. But if you go to the foot, under the foot and the skin, those are two different materials and two different boundaries. So the wave that's going to come back will have differences in intensities. So we can therefore be able to observe that, hey, this is the eye of the baby. This is the head of the baby. Hey, this is a different structure. This is not this. This is not this. And we're measuring that by looking at the intensity. So that is how we are able to do that. So a simple question that you can be asked is, for example, outline the use of ultrasound to obtain diagnostic information about internal body structures. Again, try this on your own, and we're going to sort of summarize whatever is happening all at once. Number one, we send an ultra pulse that is generated by vibrations of a quartz crystal. We have a quartz crystal, vibrates, generates ultrasound. A gel is applied on the skin to minimize reflections. For now, just put this as a point. We'll come back to why it is important. So we're applying a gel on the skin of the mother. to minimize reflections from occurring. The ultrasound pulse is reflected at the boundaries and detected by the pulse crystal. So you arrive at a particular boundary, the ultrasound comes back and is detected by the quartz crystal. So the time delay between generation and detection will tell you how deep that boundary is. And then the intensity of the reflected wave will give you information about the nature of the boundary. Is it the same boundary because you have the same intensity, or is it a different boundary but you have a different amount of intensity? You should be able to use ultrasound in that manner. So all you just need is a machine that can generate ultrasound. It gets reflected, it comes back, and you're able to detect it using that exact same machine. I know you have a lot of questions. If you have them, please put them in the comment section and I'll be happy to address that. But that is essentially how ultrasound can be used to view medical imaging. In the next video, we're going to really look in depth what exactly is reflection, what exactly is absorption of ultrasound. I'll catch you in that video.